Let us see more examples about these discrete random variables. So we are going to know this question, then we handle questions when they give now the PDF as a formula. Here they are giving it to you as a summary, but now in these ones they are going to give it to you as a formula. We are going to see how you handle it. Start with this one. A random variable capital X has a PDF shown below. This is it. Find the value of A, state the mode, and so on. What we do, set the value of A is the probability when small x is 2. That one, you don't waste time, you have all these probabilities. What you do, you know that when you sum all these probabilities, you get a 1. So when we have a 1, we know that the sum of all probabilities of all small x is a 1. So meaning when I add this, and this, I'll get 1. So 0.1 plus 0.2 plus now A plus 0.1 plus 0.15 should be 1. So this will give me A plus, this is 0.3, 0.4, 0.55 equaling 1. Set my A and I subtract. I get 0.45. So this is my value of A. So now we have the value of A in that table there. Remember 2, the one that stated the mode. Stated the mode. The mode, you say the mode is the one with the highest probability. And start when you compare this S one with the highest probability. So our mode is X equaling to 2 bracket 1 highest probability. Highest probability. Probability. Why? Because that B when X is 2 is 0.45. So that's the highest probability. I come to number 3. Remember, we said here signs are very important. Probability when X is greater than 1. When X is greater than 1, so values when X is greater than 1. So it's that when it's greater than 1, greater than 1 means we start from the next integer. So this will be now probability, the next integer is 2 plus probability when X is 3 plus probability when X is 4. We stop there because the highest value of X, small x we have is that. Then you just put in these probabilities. When X is 2 is A, which is 0.45, plus when X is 3 is 0.1. When X is this, we are putting in these probabilities is 0.15. When you add here, I think we are going to get 0.7. So that will be our answer. When I come down to this probability, marginal form, that probability when X is less or equal to 2. When X is less or equal to 2, means that we now, because it's less or equal to, so it means that now we also take 2. So it means that we start from X is equal to 2, then the values which are less than or equal to 2, we have 2, 1, and 0. That's why I'm having 1, then plus the bracket when X is 0. So it starts then when it's equal to 2 is 0.45, when it's equal to 1 is 0.2, and when it's equal to 0, it's 0.1, and when you add those ones, you get 0.75. As simple as that. So now, when I come to Roman numeral 5, you see the Roman numeral 5, the one that's got a probability of X above 0, but equaling 3. Now you see, this means X above 0. Above 0 we have 1, 2, and 3. But it's less or equal to 3. So we're going to take this, and this. This is the probability when X is 1. Probability when X is 2. Probability when X is 3. Substituting them there. For 1 is 0.2 plus 0.45 plus 0.1, which will be probability of when you add these ones, we get 0.75. I think now, members, you can handle these last two. This one means greater or equal to. Okay, let me hand this and I write, let me complete. 2 less or equal to x less than 4. This will be now. Means that now we need a 2 because of this equal sign. So now we are going to start from probability when x is equal to 2 plus the next will be probability when x is equal to 3. Now we say below 4. So below 4 there is no equal, so we can't include the 4. Here you include the 3 because it was less or equal to 2. But this one is just less than 4. And those will be the probability. Substitute them 0.45 plus when x is 3, 0.1. And this will give you 0.55. As simple as that. So you can add, I think, the last part. When it comes to this, I remember that x has a PDF given by this. Determine the value of constant k. What do we have? Then that's that our probability is x equal to x is this when x is equal to 1, 2, then 3. Meaning for every corresponding value of x, we shall be getting the corresponding value of k. So we said when x is 1, what do we have? Our probability of x, now this is small, will be 1 equal to 2. When we put here 1, we have 1 times that, which is k. When small x is 2, we have probability of x equal to 2, which will be k into 2. We are putting the 2 where this x is, we are putting the 2, and this will give us 2k. When x is equal to 3, we have probability of x equal to 3, which will be k into 3, which will be 3k. Now these are our probabilities. We need to find the value of these constants. But we know that when we sum all these probabilities, when we sum all of them for all the values of small x, we get 1. What does it mean? It means that when we sum k plus 2k plus 3k, I get a 1. This one gives me 6k equal to 1. Implying that 9k is 1 over 6. So when I have k as 1 over 6, I can easily come here and I get these probabilities, all of them. These are now my probability when x is 1 is going to be 1 over 6k. Then my probability when x is 2 is going to be 2k. So 2 times this, we get 1 over 6. It's better you leave them, don't reduce them, so that you can easily add. This will be 3 over 6. It's better you don't reduce them, as you are going to see them in there. So, after getting the value of k, now we come and we substitute them there. So now they want us to get probability, part B, they want us to get probability when x is below 3. Below 3 means we have now, below 3 we have 2 and 1. This will be the probability when x is 1 and probability when x is 2. So, probability when x is 1 is 1 over 6 plus when x is 2 is 2 over 6, and when you add, get 3 over 6. Now here you can reduce your answer like that. So it's better you read them with this denominator so that when you are adding, it's easier for you. When you come now to this, you want us to get the probability. Allow me to do this. Probability when of 2 less or equal to x, less or equal to 3. And this will be probability when x is 2 plus probability when x is 3. Why? We are starting from 2 because of this equal sign. They are ending at 3 because of that equal sign. When x is 2, we have 2 over 6. And when x is 3, we have 3 over 6. When you add, get 5 over 6. So that's how we handle that. Now, the next lesson, we are going to see how do we get the mean of a random particle, which is discrete. I wish you well.